Hello students, welcome to today's session on stress and strain graph. It's a very specific topic from the unit mechanical properties of matter and quite relevant and a theoretical conceptual topic. So we see this graph which can be drawn, which can be plotted between the two entities, the strain and the stress, x and y direction irrespectively. Okay. First, aiming the proportion limit. So what is the proportion limit? It is the limit in which the Hooke's law is valid, that is f is equal to minus k times of x. The validity of this law belonging to in this certain range is what you call to be the proportional limit. Elastic limit, these are certain terms which must a candidate must know before appearing in the exams. Elastic limit is the maximum stress which on removing the deforming force will make the body to recover completely its original state. Yield point, the point beyond elastic limit, that means this point, beyond the elastic limit. If this is the elastic limit, elastic region, this the point beyond it. That means beyond means above. At which the length of wire starts increasing without increasing the stress. The wire is increasing, but the stress has reached its zenith. It cannot move much higher. Is called as the yield point. Is called as the, the maximum. Where did I went wrong? Actually, I missed it, I guess. Yes, elastic limit. The maximum stress which on removing the deforming force, if we are removing the force which is causing deformation in that particular solid, can be seen to recover completely its original state. That's what you call to be as the elastic limit of that particular solid. The yield point. Yield point is the point beyond the elastic limit, the point beyond the elastic limit at which the length of the wire starts increasing. The length will increase, but stress won't increase, is what you call to be as the yield point. That is the yield point. That means the maximum yielding point is achieved. It is just the case of saturation in other parts of physics and chemistry, which we see. Breaking point. This is the position when the strain becomes so large that the wire breaks down at last. Okay, the strain is increased to those proportions that the wire is breaking and is called the breaking point. And at this position, the stress which is acting in that wire is called the breaking stress. Okay, the stress which acts upon in the wire is known as the breaking stress. And all the terms related are given a breaking prefix, which we call. Okay, and the strain is called the breaking strain. Elastic after effect. Now, when we consider elastic after effect, we know that some material bodies take some time to regain their original configuration when the deforming force is removed, when the forces which is causing deformation in that particular substance is getting removed. Some material bodies take some time to regain their original configuration. We have seen just like in terms of hard plastic, we see it. Yes, this delay, okay, is called the elastic after effect. As the name suggests, elastic after effect. That means the deforming forces are removed, but the body is taking its original configuration, taking some time. That particular effect is known as the elastic after effect. There are certain updates in it, just like quartz or phosphor bronze, which are used in galvanometers and electrometers, which are reducing the elastic after effect, basically. Then you have the elastic fatigue. The loss of strength of the material due to the repeated strains on the material is called the elastic fatigue. That means due to the repeated strains, due to the repeated strain which you are causing, okay, the loss of the strength, that means if you are causing deformation in a particular substance, its particular strength is getting lowered. That particular thing is why the bridges are declared unsafe after a long time of their use, because it every object in the world has a particular shelf life. The shelf life is reached, that means elastic fatigue has reached scientifically. Creep. If a small force, this term is not there in the NCRT, like, okay, but it's important for all the exams. If a small force is applied for a long time, then it causes the breaking of that particular metal. For example, a fan is hung for 200 years, then the shaft will break. Exactly, without even causing any kind of changes. Okay, so that's known as creep. Quite ironical word. Elastic hysteresis. Elastic hysteresis is multiple times asked in the CBSE boards and is of great relevance. Elastic hysteresis, this strain which persists even when the stress is removed. When you remove the stress and the strain which persists is actually called as to be the elastic hysteresis. The lagging behind of that strain is called the elastic hysteresis. The curve which we can see in hysteresis graph of ferromagnetic substance and magnetism chapter also. The same hysteresis concept is getting used here also, which we will be studying in class 12. This is the reason why values of strain for same stress are different while increasing the load and while decreasing the load. Okay. And breaking stress, the formula force upon area is very important. Now, breaking stress delivers the tensile strength of any object. Metals with small plastic deformations are known to be as brittle. Okay, that means if there is small plastic deformation has taken here to be the term or the benchmark standard for every metal to judge. With large plastic deformation, you can term that particular metal to be ductile, but with small, you will be naming them to be as brittle. So physics also has certain such concepts which are highly conceptual, less numerical. So you must be very much aware of it. Plus, you need to go well with the labelings of the NCRT graphs which are there. I'll be seeing you in the next session. Till then, keep practicing, and if you have any doubts, please revert me over my urban profile. Thank you so much, students. Thank you.